ముందుగా ప్రియమైన విద్యార్థులకు మరియు వారి తల్లిదండ్రులకు నమస్కారం. నా పేరు కె వెంకన్న జూనియర్ కాలేజ్ చైర్మన్. నేను ఈ రోజు 10th క్లాస్ విద్యార్థులను దృష్టిలో పెట్టుకొని మాట్లాడడం జరుగుతుంది. అది ఏమిటనగా, మనందరికీ తెలుసు, గత 2 సంవత్సరాలుగా కరోనా కారణంగా విద్యార్థులు ఎటువంటి పరీక్షలు రాయకుండానే పై తరగతులు పంపడం జరుగుతుంది. ఫలితంగా ఐఐటి జేఈ మరియు నీట్ లాంటి జాతీయ స్థాయి పరీక్షలను సాధించడం కష్టతరం అవుతుంది. దీనిని అధిగమించడానికి మరియు 10వ తరగతి పరీక్షలో అత్యధిక మార్కులు సాధించడానికి నేను మీ ముందుకు కె వెంకన్న జూనియర్ కాలేజ్ ప్లాట్ఫామ్ ద్వారా అనుభవజ్ఞులైన అధ్యాపకులచే ఉచిత వీడియో క్లాసులు, హ్యాండ్ రిటన్ నోట్స్ మరియు గత ప్రశ్నపత్రాల సమాధానాల విశ్లేషణ ఇవ్వబడును. కాబట్టి నేను విద్యార్థులకు చెప్పదలుచుకున్నది ఏంటంటే, ఈ ఉచిత వీడియో క్లాసులను మరియు హ్యాండ్ రిటన్ నోట్స్లను క్లాస్ రూమ్ లో కూర్చొని చదువుకున్నంత సీరియస్ చదువుకోవాలను. ఇంకొకటి ఏమిటనగా, ఈ యొక్క క్లాసులు విన్న వెంటనే అర్థం చేసుకొని ప్రాక్టీస్ చేయవలను. ప్రాక్టీస్ చేయడం అంటే కేవలం చదవడం కాదు, పేపర్ మీద రాయవలను. అలాగైతే గుర్తుండిపోతుంది. దీంతో పాటు మీ యొక్క నాలెడ్జ్ ని పరీక్షించుకున్న కొరకు త్వరలో ప్రీ ఫైనల్ పరీక్షలు కూడా నిర్వహించబడు. ఈ యొక్క అవకాశాన్ని సద్వినియోగం చేసుకోవాలని 10th చదివే విద్యార్థులకు విజ్ఞప్తి చేస్తున్నాను.
It is making some angle, but here it is 90 degrees. If it is 90 degrees, it is called right. Right angle means 90 degrees. In that case, we say that as right circular cone. Otherwise, it's simple cone. The height of the cone is generally represented by h, and the slant height of the cone is represented by L, and the radius of the cone is R. The diameter of the cone is 2R. What are the geometrical formulae from this? Now you look at this particular right angle triangle. This is H, this is R, this is L. How H, R, L are related to each other? You know that a Pythagoras theorem. By Pythagoras theorem, H square plus R square is equal to L square. So you can say that L square equal to H square plus R square. Whenever two of them are given, a slant height, radius and height of a right circular cone are given. Two of them are given, the third one can be found out. Sometimes slant height is given, sometimes the height is given, sometimes the radius is given. Whatever it be among the three, whatever two are given, you can find the third one with the formula L square is equal to H square plus R square. And what about the area? What is the base area? Base area is pi r square. Am I right? What is the base area formula here? Pi r square. What is the lateral curved surface area? What is the LSA? Lateral surface area or curved surface area? It is pi r L. The curved surface area of a right circular cone is pi r L, and the total surface area is pi r L plus base area, pi r square. Pi r L plus pi r square is total surface area, pi r square plus pi r L. So you take pi r as common, r plus L. So pi r times r plus L. What about the volume? The volume is a very important point of this. The volume of a right circular cone is 1/3 pi r square h. You can take this as 1/3 pi r square h. It is exactly 1/3 of the cylinder volume. So if you take a cylinder having got the base a circle and the top a circle having got radius r, what is the volume of it? Pi r square h. Exactly 1/3 of that is the cylinder which is inserted in the right circular cone. I am drawing the figure here. Just look at this figure. It is a right circular cone and it is the right circular cylinder. This particular volume inside this is 1/3 of the total volume. Total volume is pi r square h, and the right circular cone inserted in the right circular cylinder having got the same height h, and the radius or units is, look at the figure. This is the radius, this is h, and this is the right circular cylinder in dotted portion. The volume is pi r square h, but the volume of a right circular cone is 1 by 3 pi r square h. Now we are left with few more figures, namely, let us take a volleyball. How a volleyball is seen, just see here. Look at the figure. It is a three-dimensional figure. Just think this, it's a three-dimensional figure. It is a spherical figure. It is a cone having got, solid having got area of cross section a circle, and length of the radius of the circle is, say for example, r. The next slice above that will be reduced to r minus 1 unit, say for example r minus 2 units. So at the vertex what happens? R becomes 0. So when you slice, when you cut the area of cross section, you will get various circles having got different radii. How the radii are changing? Say if it is 7 centimeter, the next you can get 6 centimeter, 5 centimeter, 3 centimeter slices you can see. That means what? There are so many circles with varying radii, and at the top the radius is 0, and at the bottom the radius is 0. That means a sphere is a solid in 3 dimensions having got area of cross section a circle having got radius r units. Then what about the total surface area? What is the total surface area of this particular sphere? 4 pi r square. There is a geometrical proof for the same, which you can learn it later. Now at this point of time not required. What is the lateral surface area? The same. You can say that the lateral surface area and the total surface area of a sphere is same. So you don't need to distinguish that. They both are the same. At the same time, you can talk about the volume of the sphere. Volume of the sphere is 4 by 3 pi r cube. 4 by 3 pi r cube cubic units. It is square units. Same thing. Total surface area is 4 pi r square. Lateral surface area is also 4 pi r square. Volume is 4 by 3 pi r cube. It is about sphere. Sphere means what? It is like a tennis ball or a volleyball, something like that. So what is a hemisphere? You talk about the same half. Just see this. We are cutting this into 2 halves. The same thing cut into 2 halves exactly at the center. You can get 2 hemispheres, 2 bowls like things. What is the total surface area of this? Half of this, 2 pi r square. 2 pi r square is total surface area. And what is the lateral surface area? Lateral surface area is 2 pi r square, and total surface area is 3 pi r square. 2 pi r square plus this particular area, which is again pi r square. Base area and the lateral surface area. LSA plus circle area, which is 3 pi r square. 3 pi r square. Then what about the volume? Exactly half the volume. Upper hemisphere, lower hemisphere will contribute half and half. So 1 by 2 into 2 by 4 by 3 is 2 by 3 pi r cube cubic units. So there are some geometrical concepts in our mensuration, solid figures, namely cuboid. We call it first, let us start from this. Prism, a triangular prism. A area of cross section is a cube, a rectangle. It is a rectangular prism which we call it as cuboid. A cross section, the cross section is a square, it is a cube. Then a pentagonal prism, a hexagonal prism, a octagonal prism. We don't consider all those prisms, but in the prisms there are 3 different cases: cube, cuboid, and prism, triangular prism. That we'll talk about later. and we learnt about a right circular cylinder, and you learnt about a right circular cone, you learnt about a sphere, you learnt about a hemisphere. So in the right prism, a triangle having got right prism, exactly vertical, the base and the top are triangles, and the vertical, it is exactly vertical, making 90 degrees, is a right prism, a right triangular prism. In that also you can know about the lateral curved surface area, which is the perimeter of the base into height. What is the perimeter of the base? Base is a triangle having got sides A, B, C. What is the perimeter? A plus B plus C, and the height is H. A plus B plus C times H is the lateral surface area of a prism, which is a right prism, or we can call it as square units. A plus B plus C times H square units. At the same time, total surface area is the area LSA plus base area plus top area. What is the base area having got three sides A, B, C? You have a formula for that. You have to call 2S, then take the area as square root of S into S minus A into S minus B into S minus C. That formula is helpful to you. And then volume is, what is the base area? Area of the base into height. Area of the base into height gives the volume of the right prism. So we learnt about, say in short, cube whose cross sectional area is a square, and the cuboid, a cuboid, and then a right circular cylinder, and then a right circular cone, and then a right circular prism, a right prism. Right prism has got exactly 90 degrees. This is 90 degrees. And then a sphere, and then a hemisphere. All these figures, solid figures, and their formulae are learnt. Now let us start doing some problems which are very, very useful and which are very important in the examination too. So I am just giving a theoretical problem now. Let us take some examples. I'll take one example. I am writing the example here. A sphere, a cylinder, a sphere, a cylinder, and a cone, are of the same radius, and height. Same radius and same height. Find the ratio of their lateral or curved surface area, CSAs. I am just saying that way. Now we are given three figures. What are the three figures here? First one is a sphere, second one is a cylinder, and the third one is a cone. Now we have to discuss in detail about all these three. First you have to draw the three figures. Now I am drawing the first figure, which is a sphere. What is the radius? Say for example arc.
Hello students, myself is Sanjay Kumar Singh and I did my B from Birla Institute of Technology, Misra, and I am having 18 years experience of teaching. Now I am associated with KVC classes. Now here the advantage which you people are going to get, that there is a technical pool of faculty, mostly from IITs. So this is one of the biggest enabler for achieving your success. The second best thing is that doubt classes and all, they are conducted in the presence of faculties. So third is that your entire curriculum, timing of teachings, all is being monitored by ITMs and NITMs. So come here and join us.
This is a sphere. And next one is a cylinder. What is the base of the cylinder? The same circle on the top, which is like this. What is the height of this? R plus R, am I right? Radius is R, this is diameter, diameter happens to be the height. Next, what is the third figure? A cone. Same cylinder, height is the same. This is radius, this is radius, this is height, and this is radius. What is the height of the sphere? Height of the cylinder is 2 times from the sphere, you can learn it. This is R, this is R. What is height? 2 times R, am I right? Therefore, H is equal to 2R. Now, for this, again H is equal to 2R, radius is R. For this figure also, what is the height? 2R. What is the radius? Is equal to R. Now what is asked? Curved surface area is asked. CSA, I call it S1. What is the curved surface area of a sphere? What is the formula for that? You learnt very recently, just 5 minutes back. What is the total surface area or lateral surface area? 4 pi r square. So S1 is equal to 4 pi r square. So I will just write it this way, S1, I call it S1, and we will compare that later. Oh, what is the cylinder here? The cylinder is having a radius, a circular cross section having radius r and height is 2r. What is the curved surface area of the cylinder? The formula is CSA is equal to, I call it here 2 pi r h. What is h? 2 pi r into 2r. 2 into 2, 4 pi r square. What is that? 4 pi r square. Now, what is the curved surface area of the cone? Pi r L. So, h is 2r, radius is r, then L square equal to h square plus r square, which is 2r square, 4r square plus r square, 5r square. Therefore, L is equal to r into root 5 units. What is curved surface area of a right circular cone? Pi r L. What is pi r L? S3 I am calling it is pi r L. What is L? R root 5. So r root 5 into r square root 5. So it is root 5 times pi r square. So now we got the 3 figures and their 3 curved surface areas. I am repeating once again. A sphere, take a sphere. A cylinder, take a cylinder here. A cone is drawn here. For the cylinder, what is the height? Diameter, which is 2 times r. Therefore, h is equal to 2r. What is the curved surface area of a sphere? The formula says that it is 4 pi r square as it is written. What is S2? It is the curved surface area of a right circular cylinder. What is the given data? The radius is, the base is the same circle, therefore radius is also the same, height is also the same. You look at these 3, they all look alike, they are all of the same height. Their bases are the radius are the same. So h is equal to 2r again, radius is r, curved surface area is 2 pi r h, 2 pi r into 2r, which is 4 pi r square. Then take the right circular right circular cone. In the right circular cone, h is there, radius is available, you have to find L, which is, what is the slant height formula? How slant height and radius are connected in a right circular cone. The formula is L square is equal to r square plus h square. Therefore, you can substitute the value here, you get L is equal to root 5 times r. What is the curved surface area? The formula is pi r L. What is L? Root 5 r. So therefore you can simplify it. Now what is asked? Find the ratio, that is S1 is to S2 is to S3. What is S1 formula? We got it as 4 pi r square. What is S2? It is 4 pi r square again. What is S3? Pi root 5 pi r square. Now, what is the common portion in all these things? R square appears to be common, cancelled. So you get 4 pi is to root 5 pi. You can cancel pi too. Pi is a irrational number which is approximated to 22 by 7. Sometimes this is given in your example in the right side bracket. Use pi as 22 by 7 is generally mentioned. So we cancelled pi also, it's a irrational number. So you get 4 is to root 5. This is the answer. You are asked to find the ratio. Find the ratio. Answer is a ratio. This is a very important problem. You can take this problem. If you want, I will explain the same problem once again. Look at the problem and take a screenshot of this. It is a very useful problem. The answer is 4 is to root 5. I will explain the same problem because it's a problem which was asked in the examination for several times. I am reading the question. A sphere, a cylinder and a cone are of the same radius and same height. 3 solids are given with dimensions. What are the dimensions? Same radius, same cylinder. Find out the ratio of their curved surface areas. That means what? The curved surface area of this sphere and the right circular cylinder are the same which we got. 4 is to. What do you mean by root 5? What is root 4? 2. What is root 9? 3. Root 16? 4. So it is more than 2 but less than 3. It is approximately 2.2, something like that. So when you take the curved surface area, first two have the same curved surface area and the third one has almost more than a little bit half more than the cylinder or sphere. That is the ratio which we are expected to do. Shall we do one more problem? Another word problem. I am just writing the problem here. A company wants to manufacture a company wants to manufacture thousand hemispherical basins. 1000 hemispherical, SPHERICAL, 1000 basins which are in the shape of hemispherical from a thin steel sheet. From a thin steel sheet. If the radius of each basin, if the radius of each basin is 21 centimeter, find the area of steel find the area of steel